So to solve an equation involving radical expressions such as t plus 5 is equal to the square root of t plus 7, the first thing we should do is make sure that everything under the radical sign, under this radical sign, is on one side of the equation, and everything not under that radical sign is on the other side of the equation. And since the equation was given to us in this form, we can continue. So now we should square both sides of the equation because we have that square root there and we want to cancel it out. So on the left, this is going to become t plus 5 times t plus 5, which we're going to FOIL in just a little bit. And then on the right, the square and the square root cancel out, so we're just left with what the radicand was. So we're left with t plus 7. So now on the left side, we want to FOIL. So we want to multiply these terms out. So we get t squared is the first term. The outer term gives us 5t. The inner multiplication gives us 5t. And then the last is 25. And this is all equal to t plus 7. Now simplifying further, we get t squared. We can combine the two 5t's since they're like terms. So this becomes 10t plus 25 is equal to t plus 7. And now the goal here is to move everything to one side and leaving the other side to be 0. And the reason is because you see that this is a trinomial. So usually when we have a polynomial that starts in a squared and that has 3 terms, we want to try to factor it. So let's subtract both sides. Let's subtract a t from both sides, and let's also subtract 7 from both sides. So our equation becomes t squared plus 9t plus 18 is equal to 0 on the right, since we canceled out both those terms. So now, since if you ever see a trinomial like this, which is just a polynomial with 3 terms, and it starts with a square, our first inclination should always be to try to factor it. So we're looking for 2 numbers, which when we multiply them, give you positive 18, and when you add them, give you positive 9. After a little bit of thinking, you see that these numbers are 6 and 3. And if you don't believe me, there's always checking. So let's check to make sure that I factored this correctly. So foiling it out, this becomes t squared plus 6t plus 3t plus 6 times 3, which is 18, which simplifies to t squared plus 9t plus 18, which is what we wanted to get at the beginning, right? So as it turns out, that worked out well. So let me just rewrite this. Since we have t plus 6 times t plus 3 is equal to 0, we know that either t plus 6 is equal to 0 or t plus 3 is equal to 0. It's a property known as the zero factor property. And then solving these 2 individual equations, t is equal to -6 or t is equal to -3. So now we have our 2 solutions. And let's circle them in red. But before we can write down that these are actual solutions, we need to check them within the original equation, because since we squared both sides at the very beginning, we might have acquired extra solutions, which are called extraneous solutions. And these are solutions which don't satisfy the original equation. So let's check to make sure that these 2 solutions work. And the way you do that is by plugging t equals -6 and t equals -3 into the original equation, which is t plus 5 is equal to square root of t plus 7. So let's do that. Let's start with t is equal to -6. So we want to see if -6 plus 5 is equal to the square root of -6 plus 7. And the way we write it down that we check is usually we put a little question mark on top of the top of the equal sign, just to let everyone know that we're checking to see whether it's true. Minus 6 plus 5 is going to give us negative 1, and we want to check to see if that's equal to the square root of minus 6 plus 7, which is 1. So square root of 1 is 1, and negative 1 is not equal to 1. So the conclusion here is that t equals negative 6 is what's called an extraneous solution. Again, it's just a solution that we found through the regular means, but it doesn't satisfy the original equation. So now you check t equals negative 6. Let's check t equals negative 3. So you want to see if negative 3 plus 5 is equal to the square root of negative 3 plus 7. Negative 3 plus 5 is going to give us positive 2. And we want to see if that's equal to the square root of negative 3 plus 7, which is 4. And as it turns out, the square root of 4 is 2. So this solution checks out. So what you want to write at the end is the solution is t is equal to negative 3. And if you want to add as a sort of side note, t equals negative 6 is an extraneous solution. And there we go.